All right, so 2 lessons today, 3.2b and 3.3a. So 3.2b, we're going to talk about graphs of derivatives. Now remember, the derivative is just the slope, okay, the slope of the tangent. So let me show you kind of just a quick example, and then we're going to do these on our calculator a lot. Okay, so take a look at just a regular basic parabola. Okay, here's a basic parabola. And if I wanted to graph the derivative of this parabola, do you have any idea what it would be? It's graphing the velocity graph. If you're in physics,
yeah, it's a line.
It's a line. How'd you know that? That's really good. Because of physics. Yeah. It's going to be a line. So what happens is on this side, you have negatives, but they're getting smaller and smaller negatives. And on this, you get a 0 here. And on this side, you get positives, and they're getting bigger and bigger. So when you graph the derivative, you get this graph right here. It's just a straight line. Okay, isn't that cool? So what do you think a cubic would be? It would be a parabola. Yeah, they're all just going to be one less. For polynomials, there's other things to graph. If I wanted to, say, graph the derivative of the absolute value function, okay, the derivative of the absolute value function, what that would be is, what's the tangent on the left side of 0? What's the slope of the tangent there? -1. So I would graph -1, and then on the other side, it would be +1. So that would be the derivative graph. Pretty cool. Do you think of it in terms of physics? I don't. I never took physics. I wish I would have. I think so, yeah. Okay, so we're going to do some of these on our calculator, though. So I'm going to teach you something called inderiv. And there is a button on your graphing calculator that's going to help you with this. If you have an old calculator, it's not very good, but thanks. Yeah, I'm sorry. An old calculator, you're going to press the inderiv button, and then it's going to give you a parenthesis where you will then put in the function, use the comma key, put in x, use the comma key, and then put in the actual number that you're finding the derivative at, okay? If you have a new calculator, it's going to look like this. D, and you're going to put x in. In this parentheses, you'll put in f of x, the function, and then it'll say at x equals whatever the number is, okay? So, for example, let's do one. Number 1. Suppose I want to find the slope of the tangent. Okay, don't forget the slope of the tangent and the derivative, same exact thing. Okay, find the slope of the tangent at a specific point. Now we did this last chapter, finding the limit as h goes to 0. It's a long process. You plug in the number at the end, and it took a long time. Your calculator can do it for you. Here's what it looks like. Let's do one. Here we go. So let's say our function is f of x equals 2x squared plus 3x. Okay, so that's a parabola, goes through the origin, and I want to find the slope of the tangent at exactly x equals 5. Okay, so there's a point on the graph. It's going to look something like this. It's going to go like this, and at x equals 5, I want to find the slope, right? You know how to do that. You know how to do it the long way. You go to the limit as h goes to 0, f of x plus h, and we do the whole thing, right? We did that last chapter. So we're going to let our calculator do it this time. So if you will, go with me to your calculator. And there's a couple ways to get to it. If you have an older calculator, you're going to press math, and you're going to scroll down to number 8, where it says inderiv. And we can all do that, even if you have a new calculator. I don't know if it's number 8 still on the new calculators. Is it?
Yeah, it is.
Yeah? Okay. So you hit inderiv, and that's what mine shows up as. It looks like that, the d dx type of thing. Okay? So what we're going to do is we're going to put x right there, because you're taking the derivative with respect to x. You're going to put the function in here, so 2x squared plus 3x, and we want to find it at x equals 5. 23. Okay? 23. So that would be the slope of the tangent You could also say it's f prime of 5 is 23. It's the exact same thing. Yeah.
Is this the same thing you did with the formula last chapter?
Yep, it is. It's exactly the same thing. Your calculator does it. Now, if you have an older calculator, who has an older calculator that doesn't have, you just, okay, let me go ahead and I'll show you. I'm going to change this to classic. That's what you guys have. You have a classic. Yeah. And so what you do is you go math 8. So go math 8, and it says inderiv with a parenthesis, right? So what you're going to do is you're going to put 2x squared plus 3x, comma, x, comma 5. Close parenthesis, it'll give you 23. Okay? So that's if you have the older one. I'm going to go back to math print because I like math print. There we go. All right, so, and I know a lot of you guys know how to find the derivative of this already because Mr. Edlin taught you. And you would get 4x plus 3. You plug 5 in, you get 23 also. And we're going to learn that shortcut today, which is kind of exciting. All right, so what if there was something that you didn't know how to take the derivative of? Like, for example, f of x equals log of x plus 3. We don't know how to find derivatives of logs yet. We will. We will before the semester's up. But let's say we want to find f prime of -2. Okay? You can use inderiv. You're not going to be able to use it all the time. But it's good for really complicated, and it's good for at a specific point. See, we're going to find the general derivative, which your calculator will not do. It will find it at a specific point. All right, so you go, and if you have a newer calculator, there's a shortcut. Do you know the shortcut?
Yeah.
Alpha window. Alpha window, and it's number 3, inderiv. All right, ddx, what was it? Log of x plus 3. Log x plus 3. And this is at x equals -2. So the slope is pretty small, 0.43 approximately. Okay? Did you get that? Now your calculator, it lies to you. It does. It's wrong. At least mine's wrong. Maybe the new ones aren't. But let's go ahead and let's have f of x equals the absolute value of x. And let's find f prime of 0. Now, that's a problem. Because what happens at 0 on this graph? There's a corner. Is it differentiable at corners? No. This has no derivative at 0. It's undefined, okay? But your calculator, it thinks it does have a derivative there. Go math, absolute value of x at 0. And it tells you it's 0. Wrong. Does the new ones, does it still say 0? Yep, wrong. If I try it again and I plug in 3 or 6, I plugged in 6. What's it going to give me at 6? 1. It'll give me 1. It tells me the truth. But it messes up there, okay? So don't trust your calculator sometimes. Trust yourself, and you know that that's a corner, and so there's no derivative at that specific point. Okay. All right, now we're going to graph some derivatives on our calculator, okay? So number 2, we are going to graph the derivatives. We're going to graph, and then we're going to identify the graph that we just graphed. Okay? The graph that we just graphed. All right, let's do some of these. First one, f of x is equal to x cubed. Okay? We're going to graph that, and we're going to graph f prime of x. All right? So let me show you how to do that on your calculator. Some of you already know what it is. Some of you don't. We're all going to know by the end of today, so don't feel so left out. Okay? Yeah. All right, here we go. Y equals, now what I want you to do is I want you to go ahead and put the function in for y1. So x to the third, x cubed. Now for y2, we're going to graph the derivative, okay? So go to wherever you have the derivative, math 8, alpha window 3. So we're going to go ddx of y1, okay? y1, do you know where to find y1 at? It's under vars. Over to y vars. Vars is right here. Go over to y vars, choose function, and then choose y1. Okay, that way you don't have to change it every single time. You just put the function in for y1, and then the second one is going to take the derivative of whatever you put in there. And then it has to be at x. If you give it a number, it's just going to graph a flat line because it's a constant. Okay, you have to say at x. All right, so let's go zoom 6. It'll graph the original. It's a cubic function. Here it comes. Anytime now, any day. There it is. And then it's also graphing the derivative. So if you're not sure which one's which, you can always go over here. Why is this so slow? Is yours slow too? Yeah, go over here. You can always...
Wi-Fi.
Yeah, it's the Wi-Fi. Yeah, it's slowing it down. You can always go over here and hit enter and turn that off. Did you know that? You can do that? You hit enter on the equal sign. It'll turn that off and it'll only graph this one. So now I'm just going to graph the derivative. And what does that look like to you? Yep, it's blank. And now? It's a parabola.
Parabola.
It's a parabola. It's a parabola. Okay, so what I would expect, like on the next quiz, which is when? Tuesday, I would expect you to maybe graph the function or maybe just graph the derivative. And then I would have you graph its derivative, which is a parabola. But then I would have you identify the graph, as in you have to come up with the function. Okay? So the function would be, if I hit trace and I plug in x equals 1, I get 3. So it's not 1, 1. It's not just x squared. What is it? It's 3x squared. That's the parabola. And some of you who know to bring the 3 down and subtract 1 off, we're going to do that. Okay. All right, let's do one that we don't know. Maybe. Something like this. F of x is equal to the cosine of x. So I want us, we're going to graph the derivative. Let's just graph the derivative, not the original function. So graph f prime of x, and then identify what f prime of x is equal to. Tell me what the function is, okay? All right, so go to your calculator, and we'll change y1 to be the cosine of x. Katie, you know the derivative of cosine x, don't you? Shh, don't tell anyone. Okay, and then y2, we're taking the derivative of y1, and let's go ahead and graph that. And I'm graphing both of them, so that's a little confusing. I should probably turn the other one off, huh? Super slow, though. Is yours that slow? I need a new calculator. All right, so let's go to y equals. I'm going to turn off the cosine one. I'm just going to graph the derivative. And this is a trig question, so I'm just going to hit zoom trig to kind of help me out to figure this out. All right, so here's the graph, and then you just draw a sketch of it as best you can. It goes through the origin, and it goes down. Can anyone identify what this graph is? Do you know what that graph is? I taught that to you last year. It's not the sign. It's almost. It's what? It's the negative sign graph. No, it's not the same thing at all. No. Is a +1 and a -1 the same thing in golf? Hayden, no, it's not. See? So sign and negative sign are totally different. Anyways, so yeah, it goes down and then up. Okay? Yeah, we're good? All right. Let's do this last one. And this one's without your calculator. Okay? So, So we hate it when we don't have our calculator. You can't do this one on your calculator. So go ahead and draw this graph. Okay? Go to -2, 0 and put a dot. And go to 0, 1 and put a dot. Okay, and draw a line between those two. And then go over here to 2, -1 and put a dot. And then 1, 2, 3, 4, 5. Draw a straight line to 5. There we go. No, this is the graph. I know, that's harder. We're not there yet. This is the graph of f of x. We are going to graph the derivative. Okay? This one's easier than the other way. The other way is so you get confused on those? When you look at an acceleration or velocity graph and then you have to say what the original... The area. Oh, okay. All right, so we're going to now graph y equals f prime of x. Now, let's remember what f prime of x is. The derivative is the slope Always think that in your mind. It's the slope of the tangent, okay? So we're going to break this up into 3 pieces like the graph is. So I'm going to start with this piece right here. And if I wanted to graph the derivative of that, I would graph its slope. And that has a constant slope. What is the slope there? Just count. Rise over run. 1/2. Perfect. So from -2 to 0, the derivative is equal to positive 1/2. Sorry. Positive 1/2. Okay? You rise 1 and you run 2. So that's the slope. Now, is there a derivative at 0? No. There's a corner there. So when you graph this, you're going to go over here to 2. You're going to put a dot. Oh, and this is 1. And then at 1/2, you're going to go like this and then draw an open circle. Okay, so I'm graphing the derivative. It's just graphing the slopes of each piece. So then from 0 to 2, this part right here, what's the derivative of that? What's the slope of the line? Down 2 over 2, -1. Good. So you go over here, put an open circle, and then go over to 2 and draw in just y equals -1. So from 0 to 2, you have y equals -1. It's actually like y prime equals -1. And then finally, the last piece, which is from 2 to 5, what is the derivative there? What's the slope? Someone said it. 0. Good. So from 2, 3, 4, 5, you're going to go like this, and then the outsides of the graph are solid, but the insides are not. Because those are all corners. Interesting, huh? Yeah, very. Okay. Okay, so that was all of 3.2. We're done. Now we're going to go to 3.3a. And we're finally going to learn the shortcut to finding a derivative. All right, so this is called rules for differentiation. Differentiation. Wow. It almost didn't fit on my iPad. But, I could keep going like that. So, yeah. All right, 3.3a. Rules for differentiation. We're going to start with the first rule, which is called the constant rule. You don't need to know these names, but it's the constant rule. And it says this. If f of x is equal to a constant, so f of x is 10 or 3 or pi or whatever, okay, then f prime of x is 0. So the derivative of all constants is 0. Think about it. A constant is a straight flat line. What's the slope of the tangent of straight flat lines? 0. Okay? Always think slope in the back of your head. Okay, so here's an example. Number 1. F of x is equal to 9. That's Andrew's favorite number. He just told me yesterday. Yeah, I never knew that. 9. F of x equals 9. And then they're going to ask you, now they can ask you a couple of things. They could say, find f prime of x, okay? They could also ask you to find dy dx. These are all the same thing, all interchangeable, okay? So they're all derivatives. So find the derivative of 9, and you would write down 0. It's that easy. All right, so that's our first rule, constant rule. Number 2. Second rule is going to be our power function rule. This is the one where you guys like to call it the shortcut. Power function rule. This works for exponents, polynomials, stuff like that. So here it is. If f of x is equal to x to the n, where n is a number, okay? It's a constant. It's a number. Then f prime of x is equal to, this is what you do. You take the n, the number up top, and you bring it down to the front, and then you subtract 1 off. Okay? That's what we've been doing a lot lately. I've been kind of referring to it. So, for example, if you have y equals x to the 4th power, okay, then the derivative dy dx, or y prime, whatever you want to call it, dy dx is equal to, what's it equal to? 4x cubed. That's it. And you can find that doing the limit process of the whole thing of f of x plus h. You'd have to do x plus h to the 4th minus f of x all over h. It will give you 4x cubed. Guaranteed. But do you want to do it that way? No. This is so good, right? Aren't you so glad you finally get to use this when you've been using it all along? All right, how about something like this? F of x is equal to 1 over x. Do you remember doing these last chapter? And you had to put x plus h on the bottom and find a common denominator. So let's go ahead. We're going to use our power rule for this one. So you might be a little confused, like, well, there's no exponent. But what you want to do is you want to change it into an exponent, okay? This is the same thing as x to the negative 1. Do you agree with that?
Yes.
Yeah. And so now let's use our power rule to find the derivative. So let's find f prime of x. So what we're going to do is we're going to take that negative 1, move it down to the front, okay? And then we're going to subtract 1 off. And so we end up getting negative 1 over x squared. Yeah, we've seen that quite a few times, right? When we did these, last chapter. Yeah. Oh, did I confuse some of you? Whenever you have a negative exponent, you got to move it down to make it positive. Yeah. Yeah, that's been a little while since we've done that. Okay, how about something like this? Y equals the square root of x. We did this one using the limit process. And we had to put x plus h into there, and we had to use conjugates to solve and all that stuff. So let's change this now to an exponent. So what is the square root of x as an exponent? 1/2. Very good. Cube root is 1/3. Okay. And so now we're going to take the derivative. Y prime equals, bring the 1/2 down, and then subtract 1 from 1/2, and you get negative 1/2. And we're going to need to fix that. Okay. A lot of the calculus part's the easy part. It's all the algebra that you have to do afterwards. That's hard. So we get y prime equals, and we're going to take this, because it's negative, we're going to move it down, and we're just going to write it like that. So 1 over 2 rad x. So you move this down, it becomes x to the positive 1/2, and x to the 1/2 is really the square root of x. You don't need to rationalize, though. You're fine. Okay. Rule number 3. Are you wondering how many rules there are?
7.
There are 6, but we're going to do 2 tomorrow. 2 Friday.
Wait, can you scroll back up?
Oh, yeah. All right. The next rule is just the coefficient rule. Coefficient. What that means is if you have a number out front, it doesn't really make it too complicated. You're just going to multiply. So if f of x is equal to c times x to the n, where c is a constant and n is a real number, then f prime of x is equal to, you're just going to bring that n down and multiply it times the c. Okay, so same idea. Bring the n down, multiply times c, and then take 1 off. So if you had something like, here's an example, y equals 30x to the 7th. Now, how would you like to find the derivative of that using the limit definition? No, I wouldn't. There's no way I would do that. No way would you do that. So what you're going to do is you're going to take that 7, move it down to the front, multiply it times 30. What do you get? 210. And then subtract 1 off. That's it. Beautiful. Isn't that fun? Okay, now, this looks weird. Let me show you a weird one. Something like this. Y equals x to the 5th over 5. Now, some people will look at that and go, whoa, that's a division problem. I got to use something else. We're going to get to that on Friday. It's called the quotient rule. You're not going to use the quotient rule. This is a constant out front. This is the same thing as 1/5 times x to the 5th. Do you agree with that? It's the same thing. Just make it easier on yourself and pull that out of there. Don't divide by 5. Make it a 1/5 out front. And now take the derivative. I'll call it dy dx this time since I haven't used that notation in a little while. We'll bring the 5 down. 5 times 1/5 is 1, and we get x to the 4th. Okay, one last rule for today. Oh, wait, let me do this one. Last one of these. Y equals 3 times x to the pi. It's kind of fun. Not because it's fun. It's just fun. Pi's a number. So you're going to bring pi down. Pi times 3. And then you're going to what? Subtract 1 off. That's fun, right? Isn't that fun? We've just been using dumb numbers, normal numbers. Okay, last rule. Rule number 4. And then we'll have like one more thing to do. All right, this is the sum and difference rule. Sum and difference rule. So maybe you've noticed all along that I've only given you one term every single time. What about when it's like plus another term, like a big polynomial, like a big quadratic or something? Okay? Yeah, you just take the, what did I do?
No, we just skip it.
No, you don't skip those, no. All right, so if f of x is equal to a plus or minus b plus or minus c, and let's say that a, b, and c are all power functions, okay? So what you're going to do is to take the derivative, you just take the derivative of each of them separately. A prime plus or minus b prime plus or minus c prime. Okay? So let me give you an example. So something like this, where we have f of x equals 2x to the 4th minus 3x cubed plus x minus 10. Okay? A big old polynomial. And we want to find the derivative of it, f prime of x. If you're finding the derivative at a point, you know, your calculator can handle that, right? But if you're finding just the overall derivative, you got to do it by hand, but you get to use the power rule. So here we go. We're just going to take each of them individually. So I'm going to bring the 4 down, and I get 8x cubed. Bring the 3 down, negative 9x squared. What's the derivative of x? It's 1. The derivative of negative 10, 0. And remember slope. It's always slope. So if I gave you a line, like y equals 2x plus 3, the derivative is 2. It's the slope. And then, they are also going to ask you to then find maybe the second derivative. So f double prime. So you would just take the derivative of the derivative. So you get what? 24x squared minus 18x. You could also ask you for the third derivative. When we get into this, it's going to be the first derivative is what? Velocity, then acceleration, and then jerk. Yeah. All right, so bring that down. For someone who's never taken physics, I sure like it a lot. And then minus 18. You can also take the fourth derivative. You know how they label that? They use Roman numerals. Instead of doing 4 primes. It's lazy. And then you get what? 48x? Oh, just 48, sorry. And then finally, if you took the fifth derivative, it'd be 0. All polynomials, you know, you take derivatives till the very end, they'll all be 0. Okay, so we're going to put this all together in one last problem. Number, I don't know. I didn't number them today. It was weird. Number example. Number E. Number EX. Number 2. I didn't label them. It was weird. Okay, so here we go. Let's say we're given y equals 4x to the 3rd minus 6x squared minus 1. Okay. And I want us to find the horizontal tangents of this curve without a calculator. Yep. Find the horizontal tangents to the curve. So we're going to find the points where we have a horizontal tangent. Do you know what those points are? They're the maximum and minimums of this graph. This is a cubic function. It probably looks something like that. I'm not going to let you graph it on your calculator, though. And I want you to find that point and that point without your calculator. Okay? Those are our horizontal tangent points. How am I going to do that? This is what you're going to do. You're going to not take a nap, no. You're going to take the derivative and set it equal to 0. You do that a lot. Huh, Katie? You did a lot, huh? Take the derivative, set it equals 0. All right, y prime. Y prime. So let's go ahead and find the derivative of this. She's here. 12x squared minus 12x. Okay? So go ahead, set that equal to 0, and solve. Now, sometimes you're going to have to solve by factoring. You might have to solve by quadratic formula. That stinks. But this one's pretty easy to solve. We could just factor out the GCF. So we could factor out a 12x. And then we're left with x minus 1. Okay? So then I get that it would be at x equals 0 and also at x equals 1. Now, if I ask you to find points, you would then have to take those x values and plug them back into the original. See, if I needed to find out what their y correspondents are, you go up to y equals. Sometimes people will go to y prime. You're not looking for y prime. You're looking for the y values here. So that would be the original function. So you'd have to plug 0 in, and if you did that, you would get -1. And then you have to plug positive 1 in. You get 4 minus 6 minus 1, which would give you what, -3? Is that right? Yeah. And then if you go to your calculator and you graph that, oh, I don't want to mess with it. You'll see that those are the points of the max and min. Yay. Okay, that's what I have for you.